Hello everyone, my name is Uditi Namdev and today I am going to explain the concept of binary search. So binary search in simple terms is basically an algorithm which finds an item from a sorted list. We divide the data into half until we find the target. It is also called as half interval search and logarithmic search. I'll explain binary search here with an example, then I'll tell you about the time complexity and further I'll explain the pseudocode for it. Firstly, let's take a sorted array of 9 elements. Here, let's take the target as 23. I've written the indices of these elements here and this is our first iteration. So we'll initialize the left pointer to the leftmost element in this array and the right pointer to the rightmost element in this array. We first find the mid value and we do that by averaging out the indices of left and the right elements. We get 4 as 0 plus 8 divided by 2 is 4. So 15 is our mid element. Now we'll have to compare 15 with our target value, which is 23. There can be 3 cases of comparison here. So the data of mid value can be equal to our target. The data of mid value can be greater than our target. The data of mid value can be lesser than our target. So we see that 15 is lesser than 23. Since this is a sorted array, we know that 23 will appear after 15. Hence, naturally, we'll eliminate this side of this array, which is the lower half of the array. So we'll only take the upper half of the array in consideration. So this data will be halved. Hence, we get only 4 elements in the second iteration. We repeat the process of initializing the left and the right pointers. So we'll shift the left pointer to one position after the mid. So 23 will have the left pointer and 51 will have the right pointer. Again, we'll average out the indices 5 and 8, which will be 6.5. Let's take the floor value 6. So the mid value is 40. We'll again compare 40 with 23, which is our target value. We see that 40 is greater than 23. So we know that 23 will appear before 40. And hence, we'll eliminate this side of this array, which is the upper half of the array. And we'll only get 23 in the third iteration. Then again, we'll compare this mid value with our target value. And we see that 23 is equal to 23, which is our target. Therefore, we found our element. This was binary search. Now we'll go to time complexity of binary search. Initially, if we take the search space of n elements, in the second iteration, it will be half to n by 2. Hence, we'll keep dividing it by 2 until we find the target element, which will be at 1 element. So as we see, if we divide n by 2 and keep dividing it, we'll be dividing it by power of 2's. Therefore, at the ith iteration, it will be n by 2 raised to I. So we'll compute 1 to n by 2 raised to I, and from this we can see that I is log to the base of 2n. And in big O notation, the time complexity of binary search is O of log n. Now, how fast is binary search as compared to linear search? Linear search has a time complexity of O of n. So for example, if there are 10 million elements in a list and we want to find the numbers, it will take us 10 million checks if we are going to apply linear search there. And whereas binary search will only take us 24 checks because log to the base of 2 of 10 million is 23.25, which is approximately 24. Hence, we see that binary search is quite efficient and way better than the linear search algorithm. Now we'll go on to the pseudocode of binary search, where I'll explain the pseudocode so that this algorithm is clearer to you. So let's assume the L, which is the leftmost pointer, as 0 and R, which is the rightmost pointer, as n minus 1. N is the number of elements in the list, which is 9, as in case of our example. So we see that the right pointer was at the 8th index. Then we compute mid as the average of L and R, and we get mid as the average of L and R. And then if the mid element of the array is equal to target, we stop since we have found our target and we return the mid value. The fourth step is if the mid element of the array is less than target, then we set L, which is the left pointer, to mid plus 1. Then the fifth step is otherwise set R to mid minus 1, since the mid value of our array will be greater than target. Then the sixth step is going back to the step 2, and hence we repeat this process until we get our target value. This concludes the lecture on binary search. Thank you so much.